Hello everyone, today we're going to be going over the January 2025 Algebra 2 Regents exam. In this video we're going to be focusing on part 1, which are the first 24 multiple choice questions. A link to this test can be found in the description of this video if you want to follow along at home, alongside videos that go over part 2, 3, and 4 of this exam, so check those out. That being said, we're going to start off at number 1, which asks us to find the exact value of sine 8 pi over 3. So all we have to do here is just plug this into our calculator. It's really as easy as that. So I'll go hit sine, make a fraction, 8 pi divided by 3, close the parentheses, and press enter. You get that it's equal to 0.866025. Well, you may be asking me, how do you know which one of these choices is equal to 0.88625? Well, it's not choice 3 and it's not choice 2 because they're negative, right? Here our answer was positive, and we also know it can't be choice 1 because 1/2 is equal to 0.5. So the correct answer has to be choice 4, but if you still don't believe me, just plug in radical 3 over 2 into your calculator, and you'll get it's equal to 0.866025. Okay? Now remember that whenever you're finding the sine of something, you can either find the sine of a degree measure, like 60 degrees or 40 degrees, or you can find the measure of a radian, right? Like 2 pi, or 8 pi over 3, or pi over 2. Whenever you're dealing with pi's, you're dealing with radians. And whenever you're dealing with degrees, well, you're dealing with degrees, right? It's in the name. So make sure if you plug this into your calculator that you're in radian mode because you're operating with a radian, not a degree. All right, number 2 says a teacher randomly divides all her students into 2 groups. She grades homework for one group but does not grade the homework for the other group, and all homework is returned to the students. She then compares the test scores for each group to see if grading homework has an effect on test scores. Whenever you're testing to see whether a treatment has an effect or an outcome, that's going to be an experiment. All right, whenever you treat 2 groups differently and you're trying to see the outcome of that treatment, you're trying to see, if grading homework has an effect on test scores, you're running an experiment, okay? You're not running a simulation because that's like something generated in a computer and not something in real life. In this case, this was a real life thing that she did in her classroom with real people, not simulated students. And we know it can't be an observational study because for you to do an observational study, you need to observe something. In this case, she's not observing something, she's doing something, right? She's literally treating the 2 groups differently instead of just observing what the 2 groups are doing. For observational studies, you never actually interact with who or what you're observing. And finally, this can't be an unbiased survey because for it to be a survey, you need to ask questions to someone. In this case, she didn't ask questions, she treated them differently and saw the effect of the treatment, which is an experiment. Number 3 asks us to find an equivalent expression to this. So all we have to do here to find an equivalent expression is just combine like terms, right? So we'll go from left to right combining these like terms. Now, in order for you to combine like terms, what do you have to do? You have to get them out of the parentheses. So let's just rewrite this outside of the parentheses, right? We have x minus 2 squared, which is equal to x minus 2 times x minus 2. And we're going to add that to 27 times x minus 2 minus 90. Now we can, how do you get rid of a parentheses? Well, you have to distribute. So we'll distribute this x on the inside. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4, okay? Now, we have to do the same thing with the 27. You have to distribute the 27 to the inside of the parentheses. So 27 times x is positive 27x, and positive 27 times negative 2 is negative 54. Minus 90 we'll just slap on at the end because we don't need to distribute anything there. Now, let's combine like terms, right? So I have no other x squared term, so that stays the same. Negative 2x minus 2x, well, negative 2 minus 2 is negative 4, so that's negative 4x, right, if you just slap on the x's at the end, right? And negative 4 plus 27, negative 4x plus 27, well, what's negative 4 plus 27? Oh, it's 23, so this has to be positive 23x, okay? So this is positive 23x, okay? Then we'll move on here. We have positive 4 minus 54. So if you plug that into your calculator, and you can plug all of these into your calculator, right? If you didn't know what negative 2 minus 2 was, let the calculator do the math for you. Don't guess. So we have positive 4 minus 54. It's going to be negative 50. And negative 50 minus 90, which is negative 140. And that's all of our like terms combined. Maybe you may be asking me, well, there's not an answer choice here. And that's because we just have to factor it, right? So the Regents made it extra hard this year for some reason. You now need to factor it out even after you expanded it. Okay, so to factor something out, you're going to split this into a left-hand side and a right-hand side. But before we do that, we have to split up this 23 into 2 numbers that add up to 23, but that multiply into negative 140. So we know that negative 140 is equal to, well, 28 times negative 5, right? I thought of that. Because 28 plus negative 5 is positive 23, but 28 times negative 5 is negative 140, okay? So we're splitting this 23x into positive 28x and negative 5x, right? And we'll just slap on the minus 40 at the end. And we see here how now we have a left-hand side. I'll write that in a different color. we have a left-hand side here and we have a right-hand side here, right? So now we just have to factor this out. So we'll take out a term from x squared and 28x. That term is going to be x. So we're left with x plus 28. Over here, we'll take out a term, negative 5. We'll be left with x plus 28. Now that you have two terms in this parentheses, we just combine it into one. So we have x plus 28, and we combine these into another. We have x minus 5. So the correct answer is x minus 5 times x plus 28, which is choice 2. All right, number 4 asks us, given the functions f of x is equal to 2x plus 5 over 2, and g of x is 3 over x, what are these solutions to f of x is equal to g of x? So when you're finding these solutions, you're looking for the x values that make f of x equal to, g of x, all right? So we could do math, right? We can set these two equal to each other. We can say that 2x plus 2.5, because that's what 5 over 2 is equal to 3 over x, and then we can, cross multiply and do a lot of math, or we can use our calculator. So I'm going to do that. So in my calculator, I'm going to go ahead and press y equals to get into the graphing portion, and I'll do 2x plus 5 over 2. And then in my second slot here for my second y equals, or my second graph, I'll plot 3 over x, and I'll hit graph. And we see here how we have two lines. Now it's important for you to understand that the solution is just the point of intersection. So here we know that we're going to have two solutions because we have two intersections. So how do we find those intersections? Well, you can go second trace and then scroll down to, you guessed it, intersect, right? Because that's how you calculate the intersection. It's going to ask you for the first curve. You're going to place your cursor at a point before the intersection. So on this line, if you read it from left to right, this is a point before the intersection because this graph is going up like this. So then hit enter. The second curve, you're going to do the same thing, right? Select a point after the intersection though. So here we're selecting a point after the intersection because this graph goes from here down and then back up like that. And when it asks you to guess, you're going to place your cursor on where you think they intersect. So I think they intersect around here. And it's going to tell you that your intersection is at x is equal to -2, okay? But remember, there's 2 points of intersection, so we'll find the second one. Second trace, press intersect, and let's find the second intersection. Select the point before, select the point after, and then hover over the intersection. And you get that the second intersection is equal to x is 0.75, right? So that lines up with choice 2. Remember, the solutions are all the x values. Choice 1 gives you the coordinate points of the solution, but not the actual solution, right? These are the coordinate points of the intersections, not the solutions. The solutions are only the x values, okay? Choice 3 is wrong because they give you the y values at the solution. And choice 4 is wrong because it makes both of the x values into a coordinate point. It's saying that -2 is your x value and 0.75 is your y value, even though you know that these both of these are your x. So you have to explicitly state that they're both equal to x, okay? Number 5 says, given f of x is equal to this polynomial and g of x is equal to x minus 3, find the quotient of f of x over g of x, okay? So quotient, think division. So what we're going to have to do here is we're going to divide these two polynomials, right? Or these two expressions. Now, which one goes in the numerator? Sorry, which one goes inside of the division sign or hat, and which one goes on the outside? Well, that's going to be determined on who's in the numerator and who's in the denominator. So whoever's in the numerator goes on the inside, whoever's in the denominator goes on the outside, right? Think about it like, 5 divided by 10, right? If you're doing 5 divided by 10, you put 10 in the division symbol and 5 on the outside, right? Because 10 over 5, this is the same thing, both equal to 2. Okay, so that's how I like to remember it. I like to, write down a fraction that I know the value or the answer to. For example, I know 10 over 5 is equal to 2, and then I arrange them inside of my division hat in the only way that'll give me 2 as an answer, which is when my numerator is inside the hat and my denominator is on the outside, right? Kind of a long explanation, but I'm sorry, guys. So next, all we have to do is just write in our values. So here I'll write in my numerator, which is f of x, or 2x to the power of 3 minus 3x squared minus 5x minus 12. And on the outside, I'll write my denominator, which is x minus 3. And now I just have to ask myself, how many times did this number on the outside go into this number on the inside? So if this confuses you, just break it up into the simplest terms. You know that 2x cubed is equal to 2 times x times x times x. And you know that x is just equal to, well, x, right? So what do these two have in common? You have an x over here and an x over here. So you can take out an x. And what are you left with? You're left with 2x squared. So x goes into 2x cubed. Well, 2x squared times. So then you multiply those two, you get 2x cubed, because we just said that's equal to 2x cubed. And here we'll have to multiply this -3 by 2x cubed. 2x squared, and we'll get that it's equal to negative 6x squared. And we'll just have to subtract. So if this confuses you, write down your top number first. So write down negative 3x squared first, then write down the subtraction symbol, right? You know that you're subtracting them, so you have to write the operation. In this case, you're subtracting them, so you write down the subtraction symbol, and then you write down the number on the bottom. So here we have negative 6x squared in the bottom, so I'll write down negative 6x squared, okay? This turns out to be positive 3x squared. So that's how you never get the subtraction wrong, all right? Write down the top number first, followed by the minus sign, followed by the bottom term, okay? And we know that 2x cubed minus 2x cubed is 0. All right, so then we'll drop down this negative 5x as if we were just doing normal division. We'll ask ourselves again, how many times does x go into 3x squared? Well, it goes into it positive 3x times, because 3x times x is 3x squared, and you can do this trick again if that confuses you. So we'll get 3x squared minus negative 3 times positive 3 is negative 9x. Okay, and we'll subtract again. So we'll write down the top number first, which is negative 5x, followed by my, I keep saying division, guys, followed by my subtraction sign, and then followed by my bottom number, which is negative 9x, and that gives you positive 4x, and then we'll drop down this negative 12 here. How many times does x go into 4x? Well, 4 times. That's 4x, and then negative 3 times positive 4 is negative 12. If we do the subtraction, this entire bottom sign is equal to 0. So what we have is no remainders, and my answer has to be choice 1. Number 6 says, Abby is told that each day there's a 50% chance it'll rain. Which simulation can Abby perform to determine the likelihood of it raining for the next 7 days? Okay, so we're modeling it. Our answer choices are modeling it with a coin flip or or rolling a pair of dice, right? So let's think about it. If you flip a coin, how many outcomes are there? Well, you can get tails or you can get heads, and you can only get one side at a time. So for example, the probability of it landing on tails, for example, is 1/2. The probability of it landing on heads is also 1/2. Remember that probability is part over whole. So the whole is everything that could happen, right? So tails could happen, heads could happen. That's a total of 2 things that could happen. And the part is what's actually happening. Are you going to land on tails and heads at the same time? No. You're going to land only on one side at one time. So your part has to be 1. It's 1 out of the 2 things that could happen. Now, if you're rolling a pair of dice, right? How many sides does a pair of dice have? Well, it has 6 sides, and each side is numbered. 1, 2, 3, and it goes like 4, 5, and 6, right? That's how dice go. Either way, you have 1, 2, 3, 4, 5, and 6 sides. So in total, if you roll a pair of dice, you're going to land on one of 6 sides. So the probability is 1/6. Now, if there's a 50% chance that it's raining, are we going to use the model that gives me a 50% chance of something happening, or a 1 in 6 chance of something happening? Well, I'm going to stick to the coin because the probability of, any event happening when you flip a coin is 50% or 1/2, which is exactly what we're trying to model here, right? We're trying to represent this 50% chance of rain through, flipping a coin or rolling a dice. Flipping a coin has a 1/2 chance of occurring, which is why we're going to choose it over the dice. And finally, we're seeing how many times it's going to rain within the next 7 days, which is why we're going to flip the coin 7 times, right? 7 times in a row to see the probability of it raining 7 days in a row. And then we're repeating it 50 times so that we can, make sure that our simulation is correct. If we flip a coin 50 times, that doesn't really make sense because we're trying to see how the probability of it raining 7 days in a row. So we'll flip it 7 times in a row, not 50 times in a row. Okay? So number 7 asks us for the solutions to 4x squared minus 7x minus 12 is equal to negative 10. Whenever you're asked to find the solutions, you're trying to find the zeros of the function, which means that you have to set everything equal to 0 here. So to set this equal to 0, we'll add 10 on both sides, okay? And we'll have 4x squared minus 7x plus 8 is equal to 0. How do I know to do that? Well, in my answer choices, I'm given a number plus minus a radical over a fraction. That tells me that I'm going to be using the quadratic formula, which is negative b plus minus the square root of b squared minus 4ac over 2a. Literally, you have the plus minus sign. That's what gave it away for me. So I know that I'm going to have to plug it into this formula, and this formula only works when the equation is equal to 0. So whenever you see plus minus in your answer choices, just think back to this formula right here. Right, so let's go ahead and let's plug in values. So your a is going to be the first term. Your b is going to be the second term, including its sign, so negative 7. So a is equal to 4, b is equal to negative 7. And finally, your c is the last term, which is 8. Okay, so let's just plug this in. Negative b is going to be negative 7 plus minus the square root of 7 squared, which is 49. All right, minus, in parentheses, 4 times a, which is 4, times c, which is 8. Okay, and this is all going to be divided by 2a, or 2 times 4, which is 8. Right, so negative 7 is positive 7, plus minus the square root of 4 times 4 is 16, and 16 times 8 is 128. 49 minus 128 is equal to negative 79, and this is all going to be divided by 8. Now, we can go ahead and choose choice 2, but you may be asking me, well, how come they have positive 79 in the square root symbol, and I only have negative 79 there? And what is this I? Well, this talks about an issue that you can't have a negative number, or you can't find the square root of a negative number. So to kind of walk around that issue, what we do is we place this imaginary number I, right? I is equal to the square root of negative 1, okay? And the thing about radicals is you can do multiplication underneath a radical symbol if you multiply by radicals. So what I mean is if you have radical a times radical b, that's equal to the square root or the radical of a times b. So if you want to get rid of this negative sign, you can say that the square root of negative 79 is just equal to the square root of 79, which is good. We can have that square root because it's positive, times the square root of negative 1, right? Because 79 times negative 1 is equal to negative 79. Okay, but instead, we have to make this, legal according to math. What we can do is we can place this I, right? We know that this radical negative 1 is actually equal to I, so instead of writing radical negative 1, which gets us in trouble in math, we can just write times I on the outside, and that's how we get choice 2. Number 8 says if x minus 5 is a factor of p of x, then which statement must be true? So essentially you have this long string of numbers, and you know that x minus 5 is a factor. So if you found a factor, you obviously factored this out, okay? So you had, a bunch of parentheses, x minus 3, x plus 2, x minus a, so on and so forth, right? You don't know what's inside of these parentheses except for x minus 5. And because you know that x minus 5 is in the parentheses, and because you factored it out, whenever you factor anything out, you always set it equal to 0. So let's think about this, right? If you multiply anything by 0, it's equal to 0. So if this parentheses, whatever's inside of here, if whatever inside of here is equal to 0, this whole thing turns into 0. So 5 minus 5 is equal to 0. So if I were to plug in 5 for x, if I said that x equals 5, or if I found p of 5, then it would equal to 0 because 5 minus 5 is 0. And whenever anything is multiplied by 0, it doesn't matter what's in these parentheses. If you're already multiplying them by 0, they're going to equal 0. So p of 5 is equal to, you guessed it, 0. All right? Remember, p of a number, f of 5, p of 5, that just means the function when you plug in 5 for x, okay? Number 9 says, in a small city, there's 22 gas stations. The mean is 212 with a standard deviation of 0.05. And they want us to find the middle 95% of gas stations in this small city. So whenever you want to find the middle 95%, or you're finding a range, you're going to take the mean, and you're going to add and subtract 2 times the standard deviation. That's just how you find it. Okay, so the mean is $2.12, and the standard deviation, well, you're going to add and subtract 2 times 0.05, which is 0.1. All right, so 212 plus 0.1 is equal to 2.22, and 212 minus 0.1 is equal to 2.02, which is going to be choice 3. All right, number 10 asks us to, again, evaluate this division here. So remember that the numerator goes inside of the division symbol and the denominator goes on the outside. So we'll go ahead and we'll do 4x squared minus 5 divided by x squared minus 1, and we'll go ahead and we'll divide it. How many times does x squared go into 4 times x squared? Well, 4 times, because x squared is equal to, x squared times 1, and 4x squared is equal to 4 times x squared. So what do they have in common? They have x squared in common, so I can technically take that out. What am I left with? 4. So it goes in 4 times. All right, that's equal to 4x squared, and negative 1 times 4 is equal to negative 4. So if I subtract these two, I'm left with negative 5 minus negative 4, which is negative 1. Now, ask yourself, how many times does x squared go into negative 1? Well, 0 times, right? Because there's nothing you can multiply by x to turn it into negative 1. So this has to be a remainder, okay? Whenever you have a remainder, you just need to rewrite it in a new form. So your quotient, or whatever the division is equal to when you have a remainder, is the quotient, the number on top, plus the remainder divided by the number on the outside, or in this case, your denominator. So my quotient, or my answer on top, was 4, and I'm going to add that to my remainder, which is negative 1, divided by my denominator, or whatever was on the outside, which is x minus 1. So my answer is 4 minus 1 over x minus 1. How come it's not 4 plus 1 over x squared minus 1? And that's because this fraction right here was negative, and the negative overpowers the positive, so the right answer has to be choice 1. All right. Number 11 asks us, for all positive values of x, which expression is equivalent to this? All you need to know here is that when you have a square root symbol, you can always rewrite it as in terms of a fraction. So x to the power of a over b, right? Whenever you have a fraction as your exponent, the numerator is going to be the power. So this is equal to x to the power of a, but in terms of radical b, right? So for example, if you had x to the power of 3 over 4, the numerator is the power. So that's x to the power of 3. But then the 4, or the denominator, is going to kind of be like the power of the radical, or like the degree of the radical. So you'll just write this number up here, like so. So in this case, you know that the square root of x, well, that's x to the power of 1. And any square root is just equal to 2, right? So the square root of x, just remember, it's equal to 1/2. And you're multiplying that by x to the power of, well, here the exponent is 11, so that goes into the numerator, and what goes on the outside is the denominator, so 11 over 4, right? Because that's kind of the degree or the power of the radical. Okay, so that's how I got these two fractions. Always remember this property. The next thing you need to remember is that whenever you have x to the power of a times x to the power of b, that's equal to x to the power of a plus b. You're just adding the exponents. So here you're going to add the exponents. You're going to do x to the power of 1/2 plus 11 over 4, which is equal to x to the power of 2 over 4 plus 11 over 4, which is equal to, because whenever you want to add fractions, you need the lowest common denominator, which is 4. So this is equal to 13 over 4. X to the power of 13 over 4, which is choice 3. Number 12 says, or asks us to find the value of this expression. So let's go ahead and let's rewrite this. This is equal to I squared times 5x minus 2i times 5x minus 2i, because you're squaring it. So let's distribute this. 5x times 5x is 5x squared. 5x times negative 2i is negative 10xi. Negative 2 times 5x is negative 10xi again. Okay, and finally, negative 2i times negative 2i is, well, positive 4i. Okay, and remember that you're multiplying all of this by I squared. So I already talked about this in a previous problem, but you know that this fancy written I is equal to the square root of negative 1, okay? So in this case, we can rewrite this. Whenever I have I squared, like I do with this positive 4i squared, if I were to square I, I'd be squaring the square root of negative 1, which just cancels out the square root, and you're left with negative 1. So I squared is actually equal to negative 1. So if I were to simplify, whatever's inside of the brackets over here, I'd be left with 5x squared minus 20xi minus 4. Because positive 4 times I squared, which is equal to negative 1, 4 times negative 1 is negative 4. And now I have to multiply all of this by I squared, which we just said was equal to negative 1. Okay? And sorry guys, I made a mistake here. When I multiplied 5x by 5x, make sure that you write it's equal to 25x squared, not just 5x squared, right? That was a mistake. Okay, so I corrected it down here, but I didn't bring it up for some reason. So here we go. Remember that 5x times 5x is equal to 25x squared. You have to multiply these two together to get 25, and then these two together to get x squared. And you're multiplying it by I squared, which is just negative 1. So negative 1 times 25x squared is negative 25x squared plus 20xi plus 4, which is going to line up with choice 2. All right. Number 13 says when 2 times f of x is subtracted from g of x, what's the result? So we're taking 2 times f of x, okay? That means that we're multiplying this entire thing by 2, because 2 times f of x is equal to, well, 2 times f of x, right? It's the same thing. So if I multiply this whole thing by 2, I have 2 times 7 over 2 squared, 7 over 2 times x squared minus 5x plus 11. This is going to turn into 7x squared minus 10x plus 22. And I'm subtracting this from g of x. So starting at g of x, which is equal to 3x squared minus 7x plus 25, I'm subtracting, in parentheses, 7x squared minus 10x plus 22. So always remember, whenever you're subtracting something, write it inside of parentheses. Okay, that's how you always get these types of problems right. Okay, because a lot of students won't write this in parentheses and they'll get the wrong answer. Okay. So whenever you're asked to, do f of x minus g of x, always write, whenever you plug in whatever g of x is equal to, make sure you plug it into its own set of parentheses like I did over here. So from g of x means that I'm going to start with g of x. So I write g of x first, and then I'm going to subtract f of x, which I'm going to write in parentheses, okay? So before I subtract this, I need to break this f of x outside of the parentheses I put it in. So I'm going to distribute this negative 1 that's outside of it, right? This not imaginary, but this invisible negative 1 over here. So I'm left with 3x squared minus 7x plus 25 minus 7x squared plus 10x minus 22. All right, and then I'm going to combine like terms. So 3x squared minus 7x squared is negative 4x squared. Okay, so these two are combined. Then I have negative 7x plus 10x, which is going to give you positive 3x. So these two are combined. And finally, I have positive 25 minus 22, which is going to give me positive 3. And this is going to line up with choice 2, right? Negative 4x squared plus 3x plus 3. So number 14 says that a manufacturer claims that the number of ounces of a beverage dispensed by one of its dispensers is normally distributed. So whenever something's normally distributed, you can model it inside of your calculator, which is what we're going to do to solve this problem. We know that it has a mean of 8.0 ounces and a standard deviation of 0.04 ounces. To the nearest tenth of a percent, what's the percent of the cups filled by this company's dispenser that will contain between 7.9 and 8.11 ounces? So if something is normally distributed, the probability it can be found underneath this curve right here. Okay, so this curve, right? I can find it underneath this curve. This curve is going to be centered around the mean. So this is going to be centered around, well, in this case, my mean, which is 8.0 ounces, and the standard deviation is 0.04. What I'm trying to find here is how many samples are going to be between 7.9, which is like around here, and 8.11 ounces in weight, right? So in other words, what is the probability that if I look at this curve, I'm going to find something that's between these two values? And the answer is, you don't need to know this, the calculator will figure it out for you. So go into the calculator, press second vars, right, to get to distributions, right? Remember, it said that it's normally distributed. Guess what distr, distr means, or it's short for distribution. Then you're going to scroll down to normal CDF, press enter, and here it asks you for a lower and upper, this symbol, and paste. Well, what could be our lower? Well, if you drew it like this, you'll never get it wrong because you'll always know that your lower bound is 7.9, right? These two are like fences and boundaries that restrict the calculator and make the calculator look at whatever's in between them. So here, we're telling the calculator the lowest value that I want you to search for here is 7.9. So that's my lower bound. So here I put 7.9. My upper bound, well, it's, the other side of this fence. So I want the calculator to look for the highest value, which is 8.11. Okay? And finally, this symbol right here, this mu symbol right here, something that looks kind of like a U, is going to be the mean, which is 8 in this case. And this symbol right here, rho, is a standard deviation, right? Which in this case was 0.04. Press enter again to paste this, and then press enter another time. And you get that the normal CDF for this is 0.9908. So 0.9908. And to the nearest of a percent, well, you just have to round this up to 0.991, which is equal to 99.1%, okay, which is going to be choice 3 in this case, okay? So in other words, after the calculator ran its simulation, it found that 99.1% of the beverages that exist here are going to fall between 7.9 and 8.11. All right, number 15 asks us, what is the value of x in the solution? What is the value of x in the solution of the system of equations below? Okay, so here's what we're going to have to do here. We have a system of 3 equations in this case. Let's just go ahead and solve them. So always start with the term that has the least amount of work or the least amount of math in it. So these have 3 variables. So we're going to start and look at the equation that only has 2 variables, 7y and, minus z. So in this case, I have 7y minus z. And there just has to be a big pileup outside my house right now as I'm recording this video, guys. People just have to go ahead and honk their horns right when I'm recording. Anyways, this is going to equal to 31. All right, so in this case, because I have minus z or negative z, I can add z to both sides. And I'm left with 7y is equal to 31 plus z, okay? And the reason why I'm doing this is I want to get z on its own. So I'm going to subtract 31 from both sides. And I get that 7y is equal to, 7y minus 31 is equal to z. Okay? So that's my first step. I want to rewrite whatever's the shortest equation in terms of one of the variables. So now I know that 7y minus 31 is equal to z. So 7y minus 31 is equal to z. The reason why I did that is because I can now turn these other 2 equations into 2 variable equations again, right? For example, look at this top equation over here. 5x plus 2y minus z is equal to negative 14. I know what z is equal to. I know it's equal to 7y minus 31, so I can just plug that in. 5x plus 2y minus z is the same thing as saying 5x plus 2y minus, and remember, whenever you plug something in, plug it in into parentheses, minus 7y minus 31, all right? And that's still equal to negative 14, right? You know that z is equal to this value, so wherever you see z, you can always replace it. Now, let's just combine like terms. I have 5x plus 2y minus 7y plus 31 is equal to negative 14, okay? And in this case, 5x minus 5y is going to equal to, right, if I go ahead and subtract 31 on both sides, negative 14 minus, all right, they're still added outside, sorry guys. Negative 14 minus 31 is equal to negative 45. So in other words, I can either solve for x or y here. Well, I'm going to go ahead and I'm going to solve for y. So if I want to solve for y, I'm going to add 5y on both sides. I'm left with 5x is equal to negative 45 plus 5y. And if I want y on my own, well, I'm going to add 45 on both sides to cancel out this 45, because then I'll be left with positive 5y. So now I have 5x plus 45 is equal to 5y. There's a 5 in every single term here, so if I divide everything by 5, I get that x plus 9 is equal to y. So all this math I got just to get another value of this variable, right? In this case, x plus 9 is equal to y. So let me make space for my third and final line of math, okay? So I know what z is equal to. I know what y is equal to, and now I know I'm going to find what x is equal to, okay? So just rewrite this up here. X plus 9 is equal to y. Now let's focus on this final equation over here, okay? I'll write this in a different color as well. I have 5y plus 4z minus 5x is equal to negative 23. I know that 5y, well, that's just 5 times x plus 9, because that's what y is equal to. 4z, I know that's 4 times 7y minus 31. And minus 5x, well, that's what I'm about to solve for. And this is equal to negative 23. 5, we'll just have to, expand this. 5 times x is 5x. 5 times 9 is positive 45. 4 times 7y is positive 28y. And 4 times negative 31. Do that right now. 4 times negative 31 is equal to negative 124. And finally, here we have minus 5x is equal to negative 23. So let's clean this up for now. Let's move all the numbers onto the other side. So we know that positive 45 minus 124 is equal to negative 79. So negative 79, I have on this side. I'm going to just quickly add that to this side. So I have negative 23 plus 79 gives me 56. So the reason what I just did here was I just eliminated these numbers so that the algebra just looks simpler for you guys. So now I have 5x plus 28y minus 5x is equal to positive 56. Okay, I just moved the 124 to this side, and I moved the 45 to this side as well. Okay, now, why do I have two variables? The only way you can solve for one variable is to just have it by itself. Well, luckily, I know that y is equal to x plus 9. So I have 5x plus 28 times x plus 9 minus 5x is equal to 56. Okay? Now what I can do is I can distribute this 28 on the outside, okay? So I'm left with 5x plus 28x plus 9 times 28, 28 times 9, which is equal to 252. 252 minus 5x is equal to 56. So 5x plus 28, 5 plus 28 is equal to 33. And I'm left with 33x minus 5x, so 33 minus 5 is again 28. So if I combine all my like terms, all my x's, I get that 28x plus 252 is equal to 56. Now I'll just subtract 252 from both sides. And I get that 28x is equal to 56 minus 252, which is negative 196. Then I can just divide both sides by 2. Negative 196 divided by 28 is going to give me negative 7. So x is equal to negative 7, which is going to line up with choice 4. So I understand this was a lot of math, but let me just break it down to you in easy steps. Your first step is going to set the smallest equation equal to a variable. So in this case, I set it equal to z. Your second step is to go ahead and plug that z, or plug that variable you just solved in for, into one of the surrounding equations. I decided to plug it into the top. When I plug this into the top, solve for another variable. In this case, I solved for y. Okay? And finally, just plug everything into the third one. Make your way down these equations, right? You're never interacting with more than one equation at a time, okay? So even though it looks like a lot of math, you're just doing 3 equations, or you're solving for a variable inside of, 3 different equations, okay? So yeah, that's all you had to do here, really. I knew that I was solving for x, so I solved for everything other than x first. So I made it in terms, I found an equation in terms of z first, then y, and I left x for last. So the thing that you're solving for, if I were solving for y, I would leave y for as the last thing I solved for, right? Because x was what I was solving for, I left it in the last step. Number 16 says the graph below shows the amount of radioactive substance left over time, and it wants us to find the daily rate of decay. So whenever you're dealing with a rate of decay, you're going to use this formula. A, or the amount, is equal to P, or the initial, times R, almost, other way around. So a, or the amount that's left, is equal to p, the initial, times 1 plus or minus the rate of decay to the power of time. Okay, so how can you figure this out? Well, you know that this is an exponential function, so you let your calculator do the rest of the work for you. All you have to really do here is find points on this graph. So I know that this point exists right here, 0, 50. At the first day, I have, well, 50 grams of the substance. And then let's see if I can find another point right here. I can find this point right here. That's, well, that's 30. 2. So I have the point 2, 30. And let's see if I can find any other points here. Along this line, any points, no other points. That's okay. If I have 2 points, what I can do is I can ask my calculator, hey, using these 2 points, construct a formula for an exponential decay. So let's do that. In order to do that, you're going to go into second stat. You're going to get a list, okay? Sorry, you're just going to press stats, okay? When you press stat, it's going to bring you to this menu. Press enter again, right? Make sure you're hovering over edit. So press enter. And then you're going to be in this form right here, a bunch of lists, right? List 1 through 6. Okay? All you have to do here, list 1 is always going to be your x values. List 2 is always going to be your y values. So plug in your x values here, 0 and 2. What about your y values? Well, that's going to be 50 and 30. And you can see here how we kind of have ordered points, 0, 50, 2, 30. All right? Go back into stat and then go into calc. Essentially, you're asking your calculator to calculate something for you, and you're going to calculate what? Well, you're going to calculate an exponential decay, right? Which is going to be expreg. EXP stands for exponential. Regression is just a fancy word for, finding an equation based on points, okay? So you're going to press enter, then just press to enter through all of these, right? The reason why you had to put a list is because the calculator is like saying, oh, well, list 1 is where all your x values are, list 2 is where all your y values are. I'm going to use these as points. Press calculate, and it's going to say that a times b to the power of x, a is 50, right? So 50 times b, which is 0.77, to the power of x, okay? And this lines up with the equation I had here. A is equal to p, which is my initial, and this makes sense, right? My initial was 50. At 0 days, I had 50 grams left, times 0.77 to the power of x days, or to the power of time. So what's the rate? Well, remember that whatever's inside of this parentheses is equal to 1 plus minus the rate. So I know that 0.77 is equal to 1 minus the rate, okay? Why is it minus? Because a decay is always minus, right? This is a general formula for growth and decay. When you have growth, it's going to be plus r, and when you have decay, it's going to be minus r. So 0.77 is equal to 1 minus r. In this case, r has to equal to 23%, or 0.23, which is 23%, okay? Which is going to line up with choice 1. Number 17 says, if 4 times 10 to the power of x minus 5x minus 2 is equal to 12, what is x equal to, okay? So right here, I have 4 times 10, 5 minus 2 is equal to 12. The first thing I want to do here is I want to divide everything by 4, just because, it's going to be a hassle multiplying this out, okay? So if I divide everything by 4, I know that 10 to the power of 5x minus 2 is equal to 3. Now, the issue here is that you're solving for x, but it's in the exponent slot, okay? So if it's in the exponent slot, how do I bring it down? Because if something is in the exponent slot, I can't really do anything with that. Well, there's a specific math function that we can use, and that's called a logarithm. Okay? Now, when you write log like this, it has a base of 10 normally, and it essentially tells you the exponent given an input. So, for example, if I found the log of 100, that's going to give me 2, right? It's just saying, well, 10 to the power of what is equal to 2, right? Sorry, it's asking you 10 to the power of what is equal to 100. Well, 10 to the power of 2 is equal to 100, which is why it's equal to 2. So in other words, it's kind of undoing whatever is in the exponent here, okay? And what you need to remember here is that whenever you have log a of a to the power of x, it's just equal to x, okay? So if you ever want to cancel out an exponent like this, you'll just do log base of whatever the base is here. So in this case, I have 10. So if I find the log base of 10 of 10 to the power of 5x minus 2, the bases match up, and it's just going to equal to 5x minus 2 on this side, because it's going to cancel out. But remember, whatever I do on this side, on the left side, I have to do on the right-hand side. So this is going to equal to the log base 10 of 3. Now, luckily, log, written like this, already just has a 10 there, right? It's implied. So you don't have to do any, you don't have to look at any special functions. You can just write log of 3. So all you really have to do here is just find the log of both sides. If you find the log of this side, you're going to be left with 5x minus 2. If you find the log of this side, well, plug it into your calculator. The log of 3 is equal to this number right here. Okay, then you're going to add 2 to both sides. So 2 log of 3, you're going to add 2, and you're going to divide it by 5 to cancel out 5 times x. So log 3 plus 2 divided by 5 is equal to 0.494. Oh, they didn't even want an exact value. They just wanted the expression, which is going to line up with choice 3. All right, I'll run it through you guys again. If you have 5x minus 2 is equal to log of 3, to get x on your own, you're going to add 2 to both sides. You get 5x is equal to the log of 3 plus 2, and then you divide both sides by 5 to get x is equal to the log of 3 plus 2 divided by 5, right? Which is going to be choice 3. Number 18 says a random sample of 152 students was surveyed on a particular day about how they get to school. The survey results are summarized in the table below, and it's asking us which statement is best supported by the data. So choice 1 says the probability of being late given that the student is a walker is greater than the probability that a student walked given that the student was late. So whenever you see given, that's what's telling you whatever's in the denominator. Okay, so whatever's in the denominator is the given. So you know that a probability is part over whole. So given a student is something, that's going to be the whole. Okay, so the probability of a student being late. Okay, so we're going to look at this section right here. These are all of the values for student being late, but it's given that a student is walked, right? Or a student walked to school. So given that a student walked to school means that it has to be in my denominator. So out of however many students walk, right? Well, what's the total number of students that walk? It's not 4, it's 4 and 18, which is 22. So out of the 22 students that walked, given, or if I only look at the students that walk, what's the probability that they're late? Well, the probability of it being late given that they walk is 4 out of 22 because only 4 out of the 22 students that walk are late. That's the probability of the first. That's the first probability. The second probability says that this has to be greater than the probability that a student walked given that the student was late. So given that the student was late means that my whole is all of the students that are late. So that's 6 plus 20 plus 4, which is going to be out of 30. And the amount of students that are late out of everyone that's late is, again, 4 out of 30. So let's see here. For probability 4 divided by 22, that's equal to 0.18 repeating. And 4 divided by 30 is equal to 0.13333. So the first probability, 0.1818, is that greater than 0.133? Sorry, 0.133. And that is true, right? 0.18 is greater than 0.13. So choice 1 has to be the correct answer because that's greater, okay? So we got lucky here that the correct answer was choice 1, but if it was wrong, you would just have to go through choices 2, 3, and 4 with the same logic. Remember that given means out of. So out of all the students that are late is given that the student was late, okay? So just remember, given goes in the denominator. Number 19 says if f of x is equal to the cube root of x plus 4, then f of inverse, or the inverse of f of x, is equal to what? So whenever you see f to the power of -1 followed by x, that's not, 1 over f of x, that's just called the inverse. So to find the inverse, you just switch the x and the y. So right now I have f of x is equal to the cube root of x, or y is equal to the cube root of x plus 4, okay? To find this function right here, you have to flip x and y. So if I flip x and y, all of a sudden I have x is equal to the cube root of y plus 4. And now to find this equation, you just solve it for y again. Okay, so it's pretty simple. So if I solve this for y, I'm going to subtract 4 on both sides to get y on its own. I have x minus 4 is equal to the cube root of y. And how do you cancel out a cube root? Well, you cube both sides, okay? So in this case, that's going to be x minus 4 cubed is equal to y, which is going to align with choice 2 in this case, okay? So number 20 says, given that an equation s of x is equal to 1.7 times sine bx plus 12, where the period of s of x is 12, what is the value of b? So let's just break this down, like the anatomy of this formula. That's what a lot of people like to say. This number on the outside is going to be the amplitude. This number on the inside is going to be the frequency. This number right here is going to be the midline, right? So we know that a period is equal to 2 pi divided by the frequency. And that frequency is equal to 2 pi over the period. Okay, so in this case, they want us to find the value of b, which we know is the frequency. So we can use this bottom formula right here, that the frequency is just equal to 2 pi divided by the period, which we said was 12. 2 pi divided by 12 is going to be pi over 6, right? Because you can take out 2 from the numerator and the denominator. So 2 divided by 2 pi is pi, and 2 divided by 12 is just 6. So you're left with pi over 6, okay, which is choice 1. Number 21 says that Jin solved the equation by squaring both sides, and what extraneous solution did he find? So an extraneous solution is a solution that doesn't make sense here. So first of all, we can solve this by finding the solutions to this equation, right? Remember, the solutions is the point or the value of x, called back to a previous problem. It's the value of x that makes both of these sides equal to one another. So if I have the square root of 4 minus x is equal to x plus 8, the only way I can set these equal to each other is if I square both sides. So x minus 4 squared is just x minus 4. The square root of x minus 4 squared is just x minus 4. And this is equal to x squared plus 16x plus 64. Okay? All I did here was I just did x plus 8 times x plus 8. So from here, all you have to do is just solve for x. So just add x on both sides and subtract 4 on both sides. So you get that 0 is equal to x squared plus 17x plus 60. Okay, the reason why I did this was because I need to factor this out to get whatever x is equal to. Whenever you solve for x, always set it equal to 0. Okay, whenever you have x squared plus something times x plus a number that's not x. All right, so the same trick here. Two numbers that add into positive 17, but that multiply into 60. Those numbers are going to be 12x and 5x, because 12 times 5 is 60, and 12x plus 5x is equal to 17x. So if I have x squared plus 12x plus 5x plus 60, I can factor out an x and get x plus 12. I can factor out a 5 and get x plus 12. And I'm left with x plus 5 times x plus 12 is equal to 0. So my x has to be negative 5, and my x has to also be negative 12, okay? These are my two solutions. So straight off the bat, we can eliminate choice 3 and 4 because they're not even solutions to this function. Right? Now, an extraneous solution is a solution that doesn't make sense. So something that when you plug it in, it doesn't always make it true, okay? So which one of these choices gives you something that doesn't make sense? Well, you can always just plug them back in, which is actually how you check for extraneous solutions. So one of our solutions was negative 5. So let's check if negative 5 makes everything up to date. So if we take the square root of 4 minus negative 5, is that equal to negative 5 plus 8? Well, the square root of 4 minus negative 5 is the square root of 9, which is equal to negative 5 plus 8, which is 3. Yeah, the square root of 9 is 3. So the square root of 9 is 3. This is good. So my extraneous solution has to be negative 12. And I'll explain it to you this way. If I plug in negative 12, I have 4 minus negative 12. That's equal to negative 12 plus 8. 4 minus negative 12 is the square root of 16. Negative 12 plus 8 is going to be what? Negative 4. If I go in my calculator and I ask it, hey, tell me what the square root of 16 is. It's going to tell me that this is equal to 4. Is 4 equal to negative 4? No, it's not equal to negative 4. So 12 is an extraneous solution because it doesn't make both sides equal to one another, okay? Number 22 asks us the expression x squared plus y squared is not equivalent to what? So all you'd have to do here really is just plug in values, right? That's the easiest way. Sure, you can go ahead and you can do x squared plus y squared times x squared plus y squared, right? And you can find out whatever this is equal to and then see whichever one of these answers is not equal to whatever this is equal to. That takes a crazy amount of time. What you can do here is you can say, well, x is equal to 2, y is equal to 3. Whichever answer choice gives you the same value as whatever you plugged in is going to be the correct answer, which is choice 2, right? Choice 1 gives you the same thing you plugged in. Choice 3 gives you the same value if you plug in these values, and choice 4 gives you the same values. Choice 2 is the only one. For example, if you plug in, 2, well, let's just do it. 2 squared is 4, 3 squared is 9, 4 plus 9 is 13, and 13 squared is 169, I believe. Maybe I'm wrong. No, it is 169. So if you plugged in 2 and 3 for all these answer choices, this one gives you 169, this one gives you 169, this one gives you 169. But what about answer choice number 2? Right, let's check it out. Choice 2, if you do 2, in parentheses, 2 plus 3 to the power of 4 plus 2 times 3 squared, that gives you 697. 697 and 169 are two different values, so this one is not equivalent because it doesn't give you the same value. All right, number 23 says the height of a running trail is modeled by the Quartic function, y is equal to f of x, where x is the distance in miles from the start of the trail and y is the height in feet relative to the sea level. So if this trail has a minimum height of 16 feet below sea level, which functions could represent a running trail whose minimum height is half the minimum height of the original trail? So the minimum height, right, is the lowest point. Okay, so in this case, the lowest point here, we can see it's negative 16. But we want a function whose minimum height is half of that. So what's half of negative 16? Well, it's negative 8. So in other words, I want to move this function so that its lowest point is actually up here at negative 8. So what can I do? Well, I can add 8 to every single point here. If I have negative 16 here and negative 16 here, negative 16 plus 8, whenever you add 8 to x on the outside, that's a translation of however many units you added up. So you're translating this 8 units up. So negative 16 plus 8 is going to be, well, negative 8, because you've just moved this entire function 8 units up, and as a result, your lowest point is going to be negative 8. Then, choice 3 also works, because it's saying that you take your y value and you multiply it by 1/2. So whatever y value you had here, you multiply it by 1/2 to get your new y value, right? So that also makes sense, because if you have a y value of negative 16 here, right, if, you know, let's say that f of 1 is equal to 16, right? Or negative 16. Well, 1/2 of f of 1, well, f of 1 we already said was 16, and then 1/2 times 16 is equal to 8, or negative 8, because it's negative 16. So negative 8 is, again, going to be half of negative 16, which is why choice 3 works. And the reason why choice 1 doesn't work is if I had y is equal to f of 1/2 x. Let's say that f of 1 is equal to negative 16. All of a sudden, I'm taking f of 0.5. If I look at this function, 0.5 is, you know, somewhere here, and that's not equal to negative 8. That's like negative 14, right? So whenever you're messing with the y's, you're going to always multiply on the outside of the f of x, okay? Which is why choice 3 is the correct answer. Nope. Sorry, guys. It's going to be choice 2 and 3, which is choice 4. Didn't mean to confuse you like that. Okay, choice 1 is the only one that doesn't work here for those reasons. Number 14 says the crew aboard a small fishing boat caught 350 pounds of fish on Monday. From that Monday to the end of the week on Friday, the weight of the fish increased by 50% per day, and they want us to find the total weight in pounds of the fish caught per that week. Okay, so from Monday to the end of the week on Friday, that's going to be 5 days, right? So on Monday they caught 350 pounds of fish. The next day they caught 15% more. Okay, so 15% of 350 is just 350 times 0.15. Okay, 350 times 0.15 is equal to 52.5. So the next day they scored, or they, you know, I don't know, caught 52.5 more pounds of fish. So if I add that to 350, the next day, so this is Monday, this is Tuesday, it's equal to 402.5. All right, then the next day is going to be, again, 15 more pounds. So 402.5 times 0.15 is equal to 60.375. So the next day, they increased their fishing size, or their load, by 60.375, okay? So that means that the next day, they would have caught 462.875 pounds of fish on Wednesday. And the pattern is going to continue. The next day, again, this number is going to increase by a factor of 0.15, okay? So if you multiply that by 0.15 and add that back, the next day, they would have caught a load of fish that was 532.3 pounds heavy, which is on Thursday. And finally, on Friday, multiply that by 0.15 again, add that back, and you're going to get that they caught, at the end of the week, they caught 612 pounds of fish. Now, does that mean that choice 2 is the right answer? No, that's a trap. Why? Because they want the total weight. Remember, total means adding everything up, the total sum of something. So the total weight in pounds of the fish that they caught throughout the entire week. So you'd have to do 350 plus 402 plus 462 plus 532 plus 612. And you get that approximately they caught a total load of 2,360 pounds of fish over all 5 of those days, right? So you just have to calculate it out, kind of brute force through it, find the weight for every single day, and then add them together. And that's the end of this section. If you have any questions, please feel free to ask me in the comments. I do more than just Algebra 2 review. So if you guys are also taking the chemistry and the physics regents, I review those videos as well. Just check them out in the description. Hope you guys learned something, and I hope you have a nice day. And if you want to follow along with this exam and go over part 2, check out the videos in the description as well.